Hello, my name is Dan Oak and I'm a student at Athabasca University, currently taking the course Computer Science 444 Embedded/Robotic Programming. And if you've been following the videos that I've been posting on the course forum so far, you'll know that I've been going through the SparkFun Inventor's Kit Guide, showing you how I've completed some of the projects and the associated coding challenges. So before going forward and watching this video, you should know that I do have videos on the course forum showing me completing projects 1, 2, and 3 and the associated coding challenges with those projects, as well as I have 2 other videos out there showing me completing the first 2 circuits associated with project 4. So I have a video showing me completing circuit 4A and a video showing me completing circuit 4B and the associated coding challenges with those 2 circuits. However, in today's video we're going to be going over the final circuit of project 4, circuit 4C, where I'm going to demonstrate a DIY version of the heads-up party game using an LCD, buttons, an RGB LED, a vibrating motor, and a buzzer. I'll start by explaining how the LCD is connected and controlled using the Liquid Crystal library, showing how the button and buzzer pins are set up in the code. In the setup function, I'll highlight the initialization process and how the code generates a random order of words from a predefined array of animals to be displayed during the game. And then as I move into the loop function, I'll demonstrate the game's flow, where the player holds the device on their forehead, and I'll explain how the time limit is enforced using the millis function for real-time countdowns, while updating the display with the remaining time. I'll also show how the function for handling game over scenarios and a winner announcement at the end. For the coding challenge, I'll discuss how I incorporated a Jeopardy theme by adapting existing tone code to play concurrently with the countdown. So again, the Jeopardy theme being that iconic da 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 da. So the challenge with that was ensuring that the theme played without blocking the countdown display, which I achieved by restructuring the code to implement non-blocking functionality. So minimal use of delay functions. I'll explain the methods I use for dynamically controlling the buzzer sounds based on time elapsed functionality, allowing the theme to play in sync with the countdown. I'll share the difficulties faced in adapting the tone functionality while maintaining smooth gameplay, ultimately leading to a fun and engaging interactive experience. And as always, I encourage all COM44 students, if you enjoyed this video or if you have any questions about anything that I may not cover, feel free to post it on the course forum and I'll try to answer as best as I can. So we're going to dive right into the SparkFun Inventor's Kit Guide, and if you've watched the videos I've posted before, you'll know that I don't read the guide in its entirety, but rather I kind of skim over it, talking about certain highlights. So in this case, again, the circuit that we're dealing with today is the circuit 4C, a DIY Who Am I game, kind of a heads-up game. And the components we're going to be using are all components at this point, if you follow the other videos at this point in the course, you should be familiar with. So LCD display, potentiometer, which is really just being used to adjust the contrast on the LCD display, as well as I'm using one to adjust the volume on a speaker. A piezo buzzer, that's the speaker, some push buttons, and jumper wires. Some other new components that we're going to be using today is a 4x AA battery holder. I'm actually not using that for this project. I'm just using a apologies. I'm just using a portable battery pack to power the through USB power. But again, the same concept exists. Using an external battery source so that your project is portable and not tethered to a computer. Because you don't need the computer, you don't need the serial monitor or anything like that. It's meant to be a completely portable project, something that you could ultimately hold up to your head and do the heads-up game. Some new concepts, not fully new for us if you've been following the videos I've been posting, but button debounce. So when working with momentary buttons, it is usually necessary to add button debouncing. Now, the simplest way to add debounce to your code is with just adding a small delay. Such as 500 milliseconds they're giving as an example here. I typically try not to use delays as much in the code because again it is blocking code and it actually stops the rest of the code from executing, which can be problematic or just affects timings with things. So I try to use time functionality, which I'll get into detail when I show the code part. And they kind of explain it here. So for a more complex example of button debouncing, you can go to the Arduino IDE, File, Examples, Digital, and Debounce, and get an example of using time functionality. I'll also be going over that in the code. We're also going to be using strings, which is a new concept for us. And strings are actually just an array of characters with a null character at the end. But for anyone who's familiar with programming in Java or C++, you're probably familiar with strings, but again, it's just an array of characters, and that's what we'll be using for our words for the heads-up display. So an array of strings, ultimately behind in the background, the trick is to use a pointer. So when you declare your array, you'll use an asterisk after the char data type. So an array of strings is really just a pointer to a char. So you can think of each string as an array of individual characters. Pointers is an advanced programming topic, so we're not really going to dive too much into it in this video, or really at all. But you can think of pointers as a variable that points to the value contained in a certain address in memory. I mean, that's a very simplistic explanation, but if you want more details on what pointers are, they don't really come into play for this project, but feel free to post in the forum. I'll be happy to answer as best I can. Or if you really are interested, I'll try to post a link showing a good example of pointers done by, I believe, a professor from MIT, uses claymation to explain pointers, and it's pretty funny. I'll try to post the link, but if not, just Google claymation explanation of pointers in programming, and it's pretty funny. It's worth a watch. So that's just on hooking up the battery. As usual, the SparkFun Inventors Kit Guide does a great job showing you the schematics and how everything's hooked up. I'm not really going to go over the hookup in this case, because again, if you watch my previous videos, especially circuits 4A and 4B, I kind of go into detail as to the hookup and the different pins associated with an LCD screen, so I won't reinvent the wheel here and repeat myself. Suffice to say that this middle pin is connected to the potentiometer because this is the contrast pin. It controls how well we see the characters on the LCD screen. So you hook it up to the wiper terminal, or the middle pin of a potentiometer, so you can adjust it, because the contrast of an LCD is dependent on a lot of factors, including temperature. So if you're using this game in a different room and the temperature's 5 degrees difference, that might affect how it shows up. We're also going to be using a push button. One end is going to be connected to ground, and the other end is going to be connected to any digital pin. It doesn't have to be PWM or anything like that. Any digital pin will do. And then the speaker we're going to hook up to one end to ground and the other end to, again, any digital pin. Right now it happens to be hooked up to a PWM pin, but that's not necessary. In my code, I actually don't directly hook up to ground. I go through another potentiometer, and that's just so I can control the volume. That allows me to increase or decrease the volume, but that's not necessary. And I have some other things for my coding challenge as well. I'm using an RGB LED, I'm using 2 push buttons, one for a hint push button, and I'm using a vibrating motor to give haptic feedback. But we'll go into that in more detail when we get into the code. So, what should you see if you complete the regular project? Well, you should see something like this. You should have a circuit done up that you can put to your forehead and have fun with your friends. But ultimately, the game begins with the category of words and then runs through a short countdown. The first round starts with the word to be guessed, is displayed in the top left corner, and the countdown starts in the bottom right. And each time the button is pressed, before the timer expires, a new word is displayed. You're pressing the button if you've guessed successfully the word. And if you win or lose, a short song will play. So either way, a song will play. It's just different depending on if you win or lose. So ultimately, all this, by the way, is describing the general program. What I'm going to be doing today is, the coding challenge, but I always go over what the general program was meant to accomplish. So the program overview is simply, you're going to generate a random order for the words to be displayed, and then you're going to show this starting countdown on the LCD, and you're going to loop 25 times. So 25 is because that's how many words the program by default starts with. You could make that less or more. I mean, it's how many words you want to go through. As long as this number matches the number of words you have, you're good to go. And ultimately, you're just going to, output a song, depending on if the player wins or loses, and output some text as well to the screen. saying you win, you lose, all that sort of thing. The code to note during this challenge. Again, as we've already mentioned, we're going to be using an array of strings. So we're going to create an array of pointers to characters, and we're going to make that constant. And again, pointers to characters are really strings. They're C-style strings. And so yeah, at the end of the day, we're just going to have an array of strings. We've made them constant so that they can't be changed during the code. We're going to be using the round function in the original code. This just rounds up or down to the nearest whole number, whatever comes in there, using standard rounding rules that you learned from grade school math. We're going to use the random function, which takes in two parameters, min and max, and this function takes a set of numbers and then generates a pseudo-random number from that set. So it's not actually random, but for all intents and purposes, it's random does. And then we're going to be going over button debounce. Now, they're using a simple delay. As I said, I'm using time functionality, a little more complex. So I'll be explaining that. And it just works a lot better than the delay. It doesn't stop your code from executing. So, but in this case, if you do decide to go with a simple delay, you just put it at the end of your loop, and the button debounce, by adding this button debounce so that the erroneous button presses are not detected. The whole point you put a button debounce in is because microcontrollers are really quick, so when I press the button, by the time I let go of it, I might have theoretically pressed the button like 20 times, just because it's counting that button press a lot of times, especially if my finger's at all moving and the contact is coming on and off of the button. So that's why we add button debounce. Basically, we make it so that when you press the button, we only factor the first press, and we don't check for someone's pressing the button again for another certain amount of time. In this case, half a second, 500 milliseconds. Functions to note. We're going to be generating random order, so this function is going to make an array that is a random ordering of the numbers from 1 to 25, and this is used to display the words for the game in a random order. Show start sequence. That's just going to start a countdown before the game starts, and output that to the LCD. And if you get, and then we're going to have a code called game over and another code called winner, and they're essentially going to do the same thing. Just when the game over code happens, it's going to play a sound and display the text game over with the player's final score. With the winning code, you're just going to say display the text you win and plays the winning sound. So essentially the same thing. Obviously you don't display a score because, well, you win, so you know the score. You're the winner. And that's essentially the regular code. Now for what we're going to do. We're going to take this a step further in this video because we're going to do the coding challenge. So we're kind of going to incorporate a lot of the original functionality, but we're also going to change the time limit. We're going to have the ability to change the time limit. I don't think I really did that because that's not really a coding challenge. The time limit is something you decide before setup. I've just used a constant saying like 15 seconds, 30 seconds. So changing that is really just typing something different into that constant. So that's not really that fun. Changing the words. So try changing the categories in the words. Again, the number of words that are used in the word arrays must match the variable of array size. Again, that wasn't really fun to me. I mean, obviously, if you were building this on your own and you wanted to play with people, you would change the words. You would just, Google a bunch of movies or things like that and put those in there, or just various categories and change the words accordingly instead of just animals, and change your array size to match how many words you had. But that's not really difficult. Again, that's all stuff that's just done when you make the program. So I didn't really find those coding challenges per se, so I didn't really focus on those. I focused on this third one here, which was changing the winning and losing songs. So by changing the tones in the winner and game over functions, you can change which song plays at the end of the game. So that's the main coding challenge I decided to do. But because that didn't seem like enough to make a video, I also incorporated the RGB LED. Anyone who's watched my previous videos knows I've incorporated that a few times. I like colors, visual feedback. I also included a vibration motor, a tiny little motor that vibrates, the same one you'd find in a cell phone. And I did that so to provide some haptic feedback, so if this was against your forehead. I also added another button and hint functionality, so you could ask for a hint. So I kind of went off script a little bit with the coding challenges, just because I didn't find the first two that challenging or that interesting. So let's get right into it. I guess before we start, we can do a quick demo. That might be the best option. So before I get into the code, we'll just do a demo. So you could charge this again with a battery pack, just using the barrel connection on your red board and using a regular battery pack. I've opted just to use a portable USB charger, just because I've got lots of these around, and I've already got the USB hooked up for when I want to upload code. So I'm going to plug this in. So the game starts. It says get ready. Just gives you a little prompt. And that's kind of the Jeopardy theme that's playing right now. Okay, so I let that game over happen. So a couple things you may have noticed. It was the Jeopardy theme was playing basically as the time was running out. I think I have it set on 15 seconds right now. So it's just doing that classic dun 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 dun. At least best as I could hear the sound. I actually found code for the Jeopardy theme. Someone who took the time already to figure out the notes that were needed online. I do reference that, I think, in my comments. But that's pretty much playing as the sound runs out. You might have noticed the RGB LED changes from green to red and kind of transitions from less green to more red with smooth transition. Starts off green when the time is full, like when the timer first starts, and gets closer to red as the time runs out. You'll notice when the game went over that this red light flashed 3 times, just indicating you've lost the game. Also, there was a distinctive sound that played. That sound was might be nostalgic for some people. I chose to do a sound play the Mario theme for when Mario falls in the lava when he loses a certain stage. So that's the sound that played. You will have noticed that the countdown happened the whole time. As I'm doing this, I'm kind of thinking I might have forgot to. I was fiddling around with the code right before the video, and I was going to change how the score was displayed, and I think I took that out completely. So I may not display the score when you lose, which is something we could easily add. I mean, it's actually in the original code, so we could quickly add it, but for this video we may not. But the haptic feedback only happens as it gets close to the time, like as you're running out of time. The vibration would typically vibrate against your head, letting you know you need to make a decision. You need to make a guess. Things that we didn't activate is I'm using this black button to indicate whether or not I want to, if I've guessed the word successfully, and I'm holding that to my head, and if I guess the word, my friends will be like, oh yeah, you got it, and then I would click the button and move on to the next word. However, if I haven't guessed the word, I can click the hint button however many times I want. There's only 3 different types of hints I give, but it'll just keep cycling back through if you just keep pressing it. But essentially, the first time I give you the category, which I think I kept all the words the same, so the category is going to be animal for all of them. Then if you press the hint button again, you'll get the first letter of the word, and then if you click it again, you'll get a scrambled version of the word. So, and then if you click it again, you just go back to, I didn't give more than 3 hints, you just go back to the category again, and then first word, and then another scrambled version of the word. It'll be a different scrambled version, but it will still be the same word. The reason I've got this circuit so confusing, if you've watched any of my other videos, I typically have a lot of circuits built at the same time. The only thing that's really coming into play for this circuit is the RGB LED, which is hooked up. One of the common terminal of the RGB LED is hooked to ground, and then the 3 other terminals representing the red, green, and blue LEDs are all going through 330 ohm resistors into wires that are connected into just some of the digital pins. I'll explain which digital pins when we get to the code, but they're all PWM pins because I'm varying the amounts of red, green, and blue that I want sent to the RGB. The button, one end is connected to the 5 volts through a pull-up resistor, a physical pull-up resistor, which is just like a 10K resistor or something like that. And the other end is connected into one of the digital pins. Actually, in this case, it's connected into an analog pin, but I'm only doing that because I lost real estate. I've ran out of digital pins because of some of the other hookups I have for some other circuitry right now. but I'm using the analog pin as a digital pin. So just so you know, the analog pins by default are set up as input, and they're meant for analog input, but you can override them and use them as digital pins if you need. In this case, I needed another digital pin and don't need that many analog pins, so that's what I'm doing there. The other circuit, I just kind of made this on a separate circuit because I ran out of room on this breadboard, which, again, if you were watching previous videos, you'll know this is from the circuit 4A and 4B. So I just added the hint button on this little breadboard, and one end is connected in just to one of the digital pins, and the other end is connected to ground through this little gray wire. There's a common ground for a lot of things. This is connected to ground. One of the ends of the piezo buzzer is connected to ground, but not directly. It connects to ground. It connects here, goes through the potentiometer, and then through the wiper to ground. So when you do this sort of configuration, what this does is it just allows you to have volume control on your piezo buzzer. So I can use this potentiometer to increase or decrease the volume. And then finally, I have this little vibrating motor. One end is connected to one of the digital pins. It connects in here through the breadboard and then through this purple wire into one of the digital pins. That's the red wire, the positive, connects into a digital pin, and the other end just connects to ground. So we've got a common ground for the button, the piezo buzzer after it goes through the potentiometer, and for one end of this vibrating motor, and then they all go to ground. And then the LCD is hooked up over here. Again, I've went over this in some of the other videos, so feel free to look those up. And this this potentiometer is the thing that controls the contrast. I'll just show you here. So that controls the contrast of the LCD. But let's start this again, and you'll see the countdown. Pay attention to the RGB LED as it fades from green to red, and then I'll cycle through the hint buttons. So again, always display heads up game, get ready, 3, 2, 1, start. I wonder if that's as loud as it's supposed to be. Yeah. I'm just going to correctly guess this so we can start over. So that plays a little Mario theme if you got it right. So I'm going to press the hint button. It's telling me the hint is animal. That's the category. I press the hint button again. It says it begins with an A. I press it again. It gives me this weird scrambled version. Oh, that's an alligator. I'm going to guess it. The next one, I'm going to press the hint button. Oh, it's animal again. No surprise to me. Begins with an M. Oh, it's os mio. Oh, that's a moose probably, but I'm going to double check. Oh, I better guess it. So it started vibrating when I got... Oh, I guess I didn't press it in time, did I not? I wasn't paying attention if I pressed it or not. So I flashed 3 times red. I'm not sure. I guess I didn't press it in time. I wasn't fully paying attention. But to the time, I was looking at different things. But you could see that this vibrated when I got really... Like the time was almost done. I think I had set it when the time's at about 80%, whatever the time limit is. That starts vibrating. So again, I could still do the hints. Oh, that's a bear. And I'll press it. So I pressed it right before the wire. Again, that's just Jeopardy. Animal? Oh, what is it? Oh, it's a moose. Ooh. Made it right under the wire. And you can see the RGB LED changing from green to red. It's getting closer to red as my time's running out. This is going to vibrate. Came right into the wire there. Actually, you know what? I've noticed that there's something wrong with the code there because that shouldn't be gaming over. I was doing the cardinal rule that you shouldn't do and fiddling with code right beforehand, changing a couple things. And I think I either commented something out because I shouldn't get game over when I've correctly guessed. Let me just try this again, but it looks like I'm going to have to restart this video and fix that code. I'm just going to guess correctly every time. I've only got it set up for 5 words, by the way. So I won when I did everything, and that played the Mario theme song, by the way. And that flash green 5 times, indicating win. So it flashes red if you lose, it flashes green if you win. So I'm gonna wait. Again, I can check the hints and realize, oh, that's beaver. Click correct guess. It's gonna be moose. Oh, that's gonna be alligator. So it's getting red, getting close. Starts vibrating in around 2 seconds. So I get under the wire. It says I get correctly guessed, but when I waited right till 1 second, it seemed to count as game over. So I'm gonna have to quickly pause the video and take a look at that. But in the meantime, just so I'll just restart it one more time. Again, the main functionality here is meant to be that when the game starts, as the timer is running out, this RGB LED changes from green to red with a smooth transition. I press this button when I've successfully guessed the word, and that moves me on to the next word and restarts everything. The hint button, I toggle through hints. I decided not to restart the hints just to get some randomness. So basically I have 3 hint options. If you press the hint the first time, it tells you the category. If you press it the second time, it tells you the first letter. And if you press it the third time, it gives you a scrambling. Now, I could have it that every time we restart a new word, that I started this back at 0. And I had that originally, and then I'm like, you know what? I'm just going to leave it. So really now, if the last thing I did was see the category, even if I get a new word, when I press the hint button, it's going to start off at showing me the first letter. That's an easy change. If you don't like it that way, just reset your hints back to 0 every time you get a new word. That's up to you. Again, the Jeopardy theme plays as we're counting down. If we get a successful guess, it plays the Mario theme associated with level clear, like when Mario jumps on the pole. If you win the game, it plays the Mario theme, kind of just if you win. If you lose, it plays Mario falling into lava, that sound. That's what's happening there. Again, the haptic feedback, that would typically be vibrating against your head. But I've just got it kind of prototyped up here because I'm just constantly using this for different circuits. That would happen when it's at 80%. You could change that. Again, I have it at times 0.8. You could make it happen a lot sooner or a lot later. I wouldn't do it much later though. And that just gives you a quick hat back. Hey, you need to make a guess now. And again, the visual feedback the whole time. I keep the display happening even during the hints, the time. But that's pretty much what's happening. So you'll just do that again. And then we'll go and I'll try to figure out what I changed and fix that and then come back. And through the magic of YouTube, it'll only be a second for you. So I caught that one in time. Oh, AU courses. This is rearranged to be comp 444. So I caught that the 1 second and it still worked. So I'm just curious. It's a moose. Alligator. So it still gave me the game over. So again, I'm going to try one more thing. I'm just not sure if I've activated at all the hint, if it's always going to be game over, because it seems like I'm catching it. Other times it's counting and moving on if I've got it at the last second. Sometimes it's not. So I'm going to activate a hint. I'm going to let the timer almost run out. Yeah, so I think it's just the timer thing. Let's do one more thing. This is just testing purposes. You guys can fast forward if you need. I just figured I'd do the testing with you guys here. I wanted to see if just activating the hint affects me. So activating the hint doesn't seem to be the issue. You'll notice it's flashing green 5 times. Now I'm going to let the time almost run out, catch it, and then go to the end and see if it fails me. It could just be the exact timing. I tried to use mostly non-blocking code, but I do have some blocking code in there, some delays. It's possible that when I'm waiting right till the end, I'm catching a delay where it's not registering the button press. So I won. So it might be that just sometimes I'm really that close and not catching the button, even though it seems like it was saying correct. I'll have to take a look at that, but I'll be back.